Okay, one more example from section 2.1. They give us a function and a point. In the directions they basically find the equation of the line tangent to the graph of this function at that point. Okay, well, what do we need to get the tangent line? Well, to get any line we need a point, which we have, and the slope. Okay, so what's the slope of the tangent line? Well, to get the slope of the tangent line we need the derivative of this function. Okay, so remember we have the limit definition for the derivative, okay, which is f of x plus delta x minus f of x over delta x. We take the limit as delta x goes to 0. Okay, so a little bit of calculation here. Okay, so what is f of x plus delta x? Well, it's going to be 2 times x plus delta x squared minus 1, okay, minus the original function, 2x squared minus 1, okay, all over delta x. Okay, so this is the limit as delta x goes to 0. Of course, again, we have to FOIL this out, which we've done several times in the past few sections. But this is going to be 2 times x squared plus 2x delta x plus delta x squared, okay, minus 1 minus 2x squared plus 1 all over delta x. Okay, so if I distribute this 2 inside, maybe I'll go ahead and do that now just to save myself a line of writing. If I multiply the 2 into the parentheses, I'll get 2x squared plus 4x delta x, okay, plus 2 times delta x squared. It's kind of crammed in there, I know, but at least now we've got everything expanded out in the numerator, and we can start canceling terms. I've got a 2x squared and a negative 2x squared. Okay, I've got a minus 1 and a plus 1. Okay, those cancel. Okay, and finally, what I have left, and again I'll have to erase it and go back up here, the derivative is the limit as delta x approaches 0 of 4x times delta x plus 2 times delta x squared all over delta x. And just as we've seen time and time again, this is the point where we can start using some direct substitution. What we have to do first is cancel. Now we have a delta x factor in every term of the numerator. So I can cancel the delta x in the denominator with a 1 factor of delta x from each term in the numerator. Okay, so that gives me the limit as delta x approaches 0 of 4x plus 2 delta x. And now there's no division by 0 when we replace delta x with 0. So it'll be 4x plus 2 times 0, which is 4x. Okay. So that's the derivative of our function. Okay, now back to the question they asked us. What's the slope of this function when at this particular point? Right? We need the slope of the tangent line. Well, at this point, x is 0. So for the tangent line, we can now really start to get everything together. We know it contains the point, 0, negative 1, and the slope of that line is f prime of 0, because that's the x-coordinate of the point. Okay? So f prime of 0 is 4 times 0, which is 0. Okay? Turned out to be a nice, simple number, 0. Okay? So the tangent line is the line containing this point with the slope of 0. We can use the point slope formula to get the line now. Okay, and again, just to kind of save a little bit of space, I'll just go ahead and plug everything in here. We get y minus the y-coordinate, which is y plus 1, equals m, okay, the slope, which is 0, times x minus the x-coordinate. Okay, so if you move everything over to one side, you'll get the tangent line is y equals negative 1. Okay, so this function has a tangent line of y equals negative 1 at that point. Okay, so now the second part of the problem, which I won't do on the board, but you can do easily enough on the calculator, is to verify that this line is tangent to this curve at that point. Okay, so again, on the calculator, you'll hit the equation editor and just graph these two functions. So when you hit the equation editor button, that's that y equals button on the calculator. Just do y1 equals 2x squared minus 1, And y2, that's the second function, which is just our tangent line, y equals -1. So hit the negative button on the bottom of the calculator to get -1. And what you'll see is that both of these functions will be graphed. Of course, this one's a parabola, this one's a horizontal line, and they will in fact agree. They will both contain the point 0, -1. And more importantly, this horizontal line will be tangent to the graph. So it'll match the steepness of the graph at that point.